Hello, in this video for Physics 1114, we are going to go over Chapter 1, Exercise 9.2, and we're going to use the unit vector method to solve this using I-hats, J-hats, and K-hats. As you can see here, we have 5 forces that we have to deal with, and I'm just going to write those down below and to tabulate them a little nicer. What I would like to do now, though, is put them into their I-hat and J-hat forms. And in order to do that, we are going to define a little bit of a coordinate system with positive and negative directions. And if you remember, we set the positive y-axis to be the positive j-hat direction. Similarly, we set the positive I-hat direction to be with the positive x direction. Negative j-hat was in the negative y direction, and negative I-hat was in the negative x direction. In other words, we use these I-hats and j-hats for x and y directions. Using these directions, I am first going to set Fn. Instead of saying 2 newtons up, I can say it as plus 2 j-hat newtons. Similarly, I can use Fap is plus 2 j-hat newtons, because they're both 2 newtons up. And I can take Fg, which is 2 newtons down, and I can write it as negative 2 j-hat newtons. Now, in terms of the right and left, force T is 6 newtons to the right. I'm going to write that as plus 6 I-hat. Similarly, the friction force is 4 newtons to the left, so I would write that as negative 4 I-hat newtons. What we are left with is all our vectors written in this handy IJK or unit vector notation. We can now use this to find the net overall force of adding these 5 together. So the first thing I want to do is just collect all the I-hats, everything that's in the x direction. So I'm going to highlight T and F as with one color, and I'm going to highlight all the j-hats with another color. And that's just to kind of keep them separate so it'll be nice and neat. So the first thing I'm going to do now is add all the x components together. And so notice here I'm going to add plus 6 I-hat plus negative 4 I-hat. And the I-hats are, you don't even really need them in the equation because we're doing the x components. It's sort of implied, but I'm putting them in there anyways. The result is plus 2 I-hat newtons. Now I'm just going to repeat it for the y components. So when I sum up all the Fy components, I'm going to get plus 2 j-hat plus 2 j-hat minus 2 j-hat, which adds up to a total of plus 2 j-hat newtons. We can now write it all on one line by writing the net force equals the sum of all the forces equals 2 I-hat plus 2 j-hat newtons. So we can write it together. We just keep the I-hats separate from the j-hats when we write it all in one line. Now this is the answer, but rarely do questions come where you have everything already sort of pre-broken down into I-hat and j-hat for you. As a result, I'd just like to show you a more comprehensive method for doing this. It's not really different, but it's just a different way of maybe laying it out that will help you in the future if you're trying these type of problems. So I've got my original set of vectors again, but what I'm going to do this time is set them up so I'm writing both I-hat and j-hat components together for each separate force. Now, as you will see coming up, this is going to be a little overkill for this problem, because everything's already either up or down or right or left. But in the future, there will be problems where you have vectors that have both up and down and right and left components together. And as a result, it makes sense to lay it out this way to get used to it for future problems. In this problem, let's look at the up and down vectors, Fn, Fap, and Fg. Now, they have no components along the x-axis, so no I-hats. So I am just going to put, for those vectors, 0 in the place where you can see the I-hats. Then, because they have j-hat components, I am just going to put for Fn and Fap, it'll be plus 2 j newtons. And in Fg, the y component is negative 2 j hats. I can do the same thing for the forces labeled T and F because they are only along the x-axis. And as a result, I can put 0 in the j hat position and positive 6 I hat for the force labeled T. And because it's 4 newtons to the left for the force labeled F, I'm right negative 4 I hat. So now I have all my forces labeled with I hats and j hats for each one. And where this makes really good sense is in order to find the net force now, I can just add them together. I just have to add the columns. So notice the column I've sort of highlighted with the I hats there. I just have to add down, and then I can do something also similar with the j hats. It keeps the I hats and j hats nicely separated. And so when I add the I hat column, I get plus 2i. And when I add the j hat column, I get plus 2j hat. And as a result, you can see that I got the final net force is plus 2 I hat plus 2 j hat newtons, which is the exact same answer we got before. I just find that this sort of bookkeeping method will help you keep the I hats and j hats separate. Now, I just want to reiterate, for a problem like this is probably overkill because we have a lot of zeros in there. So I know a lot of you who are watching will be like, well, wait, do we have to do it this way? Because it seems like a lot of extra writing. And you're absolutely correct. Probably for this, it is a little more than you need. But later on, you're going to be dealing with problems where you have I hats and j hats on the same line. And as a result, this is a good way to kind of get used to that format because I think this will really help you as the problems get more complicated over the coming weeks. Now, this is the solution to the problem. There is another way to do it with the tip-to-tail solution, or we sometimes call it the head-to-tail solution, where we do it graphically. I'm going to do another video on that. So try to look that one up, and you can see another way to solve this problem. In the meantime, of course, if you have any questions about this, please feel free to get into contact with me. I'm happy to help in any way I can. But other than that, I'd like to thank you for watching, and I hope you have a great rest of the day.